In this video, we will try to understand what is the importance of null design pattern. Now, in order to understand any design pattern, it is very important to understand in what scenarios that design pattern is used, or I will say what problem that design pattern solves. Once you know what problem the design pattern solves, it is very easy to implement design pattern in your project. A lot of developers think that null design pattern helps you to avoid null checks. Now, as a developer, I don't have to explain you what is the importance of nulls. Nulls signify some kind of an error. So when you get a null, it means that something is wrong, right? Nulls signify something is not existing. Nulls are needed, when you want to indicate a value which is neither zero, neither empty. So nulls are important. A lot of times when I openly speak about my love for nulls, a lot of people point me to this small video which is recorded in 2009 by Mr. Tony. Mr. Tony actually introduced nulls, or I'll say he invented nulls. And he himself says that null is a $1 billion mistake, but I have a different view for that personally. Personally, I feel that we need a value which is between 0 and empty. Null. Null means nothing, right? So definitely I need nulls. I need nulls to indicate errors. I need nulls to indicate emptiness. I need nulls to indicate that something has not been found, right? Nulls are needed in application. If you swallow errors of nulls, then you will have bigger problems in detecting those defects, right? So if null design pattern does not solve the null error or null handling, so what does it exactly do? So let me put a definition around nulls. Null design pattern actually helps you to fill absence of an object. Or I will say null design pattern actually helps you to give a default behavior in collaboration. Again, I repeat, null design pattern helps you to fill an absence of an object, or it helps you to give a default behavior in collaboration. This word collaboration is very important. So now let us think about a collaboration scenario between two objects. Let us say you have an order object, and that order object is actually using a discount object. So in other words, you have an order class, and that order class is using a discount class, right? So you have a scenario where you have an order object, and in order to calculate discounts, this order object is using the discount object. Now let us say that this order class has an order number and an order amount. So there is an order number and there is an order amount in this order class. And this discount class over here calculates discount. So this discount class actually calculates discount on the basis of order amount. So it takes in the order amount and it calculates discount. Now let us assume that you have a lot of discounts, different types of discounts. Let us assume that you have discounts which calculates as per weekends. Then you have discounts calculation which is as for new year, right? So you have different now types of discount calculation logic. So what do you think as a developer, that if this order class wants to use this discount logic, then it is better to go via an interface, right? Because why? Tomorrow when you add a new discount class, then you don't have to make changes to the order class. So what you do normally, when you want to decouple two classes, you put a interface in between. So I will go and put an interface here called as iDiscount, and this interface will have this method, and this method will be implemented by all the child classes or all the classes, right? So all these discount classes will now use iDiscount. So this normal discount calculation uses iDiscount, the weekend discount calculation uses iDiscount, and the new year class also uses the iDiscount. And now your order class will only talk via iDiscount. So now at the back end, you can have a discount class, you can have a weekend discount, you can have a new year discount, you can have whatever, right? So tomorrow you can go and add a new discount logic at the back end, but your order class is completely decoupled from those changes. So normally when you see developers, they program like this, and what normally developers do, they via the constructor, they use dependency injection and they pass these kinds of objects. So over here, I'm passing the discount object or discount reference through the constructor, right? Okay. I would advise you to go and see the dependency injection video. So we have two videos. One is inversion of control and dependency injection. And this thing, what I've done at this moment here is nothing but your inversion of control, right? So I will suggest that if you can go and see the video of inversion of control, you would understand what I've done over here. And this order class will be now calling this discount object internally to calculate discount. So now if you want to use this order object, it will be as follows. So I will say here order or1 is equal to new order, right? So now let us say I want to use the weekend discount calculation, right? So I can use the weekend discount calculation. I can pass in the I need to pass the order amount. So let us say 100, and if I call the discount function, I would get the discount output, right? So there it is. Okay. So if I say Control F5, depending on whatever is the order amount, you can see that it is that weekend discount calculation is giving me 90. Now I can go and change this to, let us say, new let me pick up now normal discount, or let us say new year discount, right? So if I run this now, I have a different discount calculation. So now this is a decent architecture. So you have the order class, and the order class is decoupled from the discount calculation because the order class is using this interface iDiscount, and this interface reference is injected via the constructor. So you are following the inversion of control principle, right? So now you can say that, okay, this order is of new year. So because this order is of new year, I'm using the discount calculation logic of the new year, right? But now let us say that you have an order which is placed on Sunday. So let us say you have an order which is placed on Sunday. So then you will actually go and use the weekend discount calculation logic, right? So now because of the flexible architecture, you can pick the order, you can pick the type of discount, and you can have a very flexible code, right? But now think about that you have an order, and this order is actually not an order. This order is a lead, or I can say this order is just an inquiry. Okay, so this order is just an inquiry. Okay, so if an order is just an inquiry, it is not an actual order, then what you would like to do is you would like to say that there are no discounts, right? So you want to say over here that there are no discounts, and probably one of the things as a developer which you will do is you will say that just pass null, because now this is not an actual order, right? But it is an inquiry. Okay. Now if you do this, then definitely your program will crash, because if you run, then your program crashes here in the order class, because in the order class you are using the discount object, and now you have injected the discount object as null, and you have a problem, right? So one of the quick fixes, what a developer normally does, he goes here and he says, okay, you know what, if underscore discount is null, then please return 0, and so on, right? So that is one way of doing it, putting if conditions and solving the problem. But think in a very logical manner. Let us give a thought on what exactly is the problem now. If you think logically, the order object is using the discount object. The order object is expecting certain kind of behavior from the discount object. But suddenly there are situations like this, where the order becomes an inquiry, and the order object expects a kind of a default behavior, or I'll say he does not expect any behavior, or we will say that he expects null behavior. Now, rather than going and putting this if condition, right, all across your code, what you can do is you can go and create a class which is actually having a default behavior, or I'll say a null behavior, right? So I will go and create a class. So I can do something like this. I will say that, okay, let us create a class called as default behavior. Now this word null, right, at this moment, if you see, I've given the name as default behavior and not as null behavior, because null is actually a technical word, right? So personally, I like this word like default behavior. So I'll say that, okay, when you want to just go and bypass the discount object, you will get the discount as 0, right? So now what I can do is I can say that, okay, for this kind of situation, rather than passing null, we will actually pass this default behavior. So now our program will not crash in this case, right? So now if I go and run my program, so you can see that the first behavior is the first discount calculation is using the new year, the second one is weekend, and the last one is a null behavior, a default behavior, or I will say it is no behavior, right? Now, if you're still thinking that, checking of nulls is more easy, now think about this. At this moment, I'm using the discount object here. Now think about this. Let us say that we have a method here called as save, right? This goes and saves the order object into database, and it returns true if it is saved successfully. Okay, so before saving to the database, again I am calculating discount here, so that I can insert even the discount into the database, right? So again you have to write the null check over here as well, right? So so in this way, you have to write the null checks all across your code of order object. But remember that the main intention of null design pattern was not to avoid nulls. Please note, it was to give a default behavior under certain scenarios. It was to give a default behavior to the order object in collaboration. So the null checks which were avoided is just a byproduct. It was not the main intention. Okay, the main intention here was to provide a default behavior or to provide a no behavior kind of a behavior, right? Also, one of the use of null design pattern which I feel is in unit testing. For example, now let us say over here you are saving the order object to the database, and before saving the order object to the database, you are actually checking if the order number is provided or not. So if the order number length is equal to 0, then you would like to return false, and you don't want to continue ahead. Now let us say that you want to only unit test the order code. You don't want to test the discount logic code over here. So in this scenario, you need some way by which you can go and bypass this code over here, or I will say you want to go and mock out this code from here, right? In case you are new to unit testing and mock testing, what I would suggest is to go and see the videos of unit testing and mock testing on questpointvideo.com, where we have explained them in more detail. But mock testing, in short, if you ask me, is nothing but you go and you mock certain objects, so that you can go and reach the other part of the code and test them in an isolated manner. So in this case, now if you see, so here is my unit testing testing project. So what I can do now is, because I have this default behavior, right? This default behavior does not have any code, right? If you look at the default behavior at this moment, it does not have any code. So what I can do at this moment is I can go and do something like this. So I can go to my unit test case. I can go and create the object of the order, pass him the default behavior, and then I can happily go and call inquiry.save, right? And bool b, right? And I can then say here assert dot r equal. So if this, the expected is true and the actual what I've received is this, right? So you can see now this save method here will actually use the default behavior, and automatically, you know, this code will be bypassed from here, and you will be only checking the order code. Now this kind of testing is also termed as regression testing, and regression testing mainly happens in the maintenance phase. If you look at a maintenance phase, in maintenance phase you only change certain part of the code. For example, in this case, probably you will just go and change the order code, and you want to only test the order code. So you don't want to waste time in testing discount or, you know, other objects. So you want to go and mock these objects out and only test this part of the code. And that's where, you know, again, I find a null design pattern very useful. So what you can do is you can go and write down the null behavior for each and every object, and whenever I'm doing unit testing and whichever code I want to bypass, right, I will go and pass the behavior, and I just test the necessary code or the changed code. So basically, null design pattern is not to avoid null checks. The null checks is a byproduct of null design pattern. Nulls are important. For example, you know, there are scenarios, you know, where you would like to say, okay, if inquiry object is null, right, then you would like to catch an exception, right? So nulls are important. For example, in this scenario, you know, where I'm checking if the inquiry is equal to null, then I don't want to continue with the program. So here I need nulls, right? So the basic goal of null design pattern is that when two objects are working in collaboration, there are certain scenarios where one object, you know, expects from the other object no behavior. So at that time we need to go and use the null design pattern. So I hope that you have enjoyed this video. And very quickly, a very quick note here. One is that, you know, we are learning these design patterns in an isolated manner. The other is, if you want to really understand the importance of design pattern, you need to do a project. So I would encourage you to go and see the series of Learn Design Pattern with a Project, which we have on Questpon VD, where we have explained 20 to 30 design pattern in the project in a very gradual manner. So one is, yes, learn this design pattern in an isolated manner, the way I am showing here. The second thing is, go and do a simple project and try to see that how these design patterns work in collaboration. So very quickly, let us revise. Null design pattern is meant to give a default behavior, you know, when two objects work in collaboration. Second, null design patterns byproduct is that null checks are avoided, but that was not the main intention of null design pattern. And second, null design patterns are very useful, you know, when you are doing mock testing or regression testing. So I hope that you have enjoyed this video. Thank you very much.